All right.
Cool. Thank you.
With that, yeah, sorry, Matt, I'm talking over you. I have the otter suit. I'm more important. So, I'm just kidding. My mitts are off. Hang on a sec. There we go. I'm all paws again. So, I'm adding in Charles here. Charles is going to be taking on our next session. Say goodbye to some of our others. Thorsten, we'll see you later. And Merrick,
thank you, everybody.
Yeah, Sebastian. So what we're going to do is we're going to transfer this over to Charles, and he's going to be taking on the next session. And with that, we're out of here. Have a great next session.
Awesome. Thanks for the intro. Thanks for everyone for organizing. Thanks for all the awesome libraries and projects. So I'll be talking about the CDK for Terraform. I am just an early adopter, sort of just getting started, really, but I thought it would be good to get this sort of end user perspective. I've really been enjoying the project. Again, just special thanks to Sebastian and Mishra and everyone who's made the CDK for Terraform possible. Just a little background on the project. I'm just kind of getting started on my day here in San Francisco, so apologies if this has been covered already. But CDK for Terraform has been out about 2 months. Still considered alpha, I believe, but we're using it in production at my job. I work for ShopStyle. We're part of Rakuten, great place to work, great company. We've got about 10 CDK for Terraform stacks, but we're very highly invested in Terraform. We have hundreds of Terraform stacks. We're using CDK for Terraform in production, and it's really going very well for us. So what I'll be talking about today is what brought us to this project, what brought me in particular to CDK for Terraform, some of my background on this project. I'll be doing some sort of live coding examples, kind of getting set up. And I will probably spend most of the time on that, talk about, some sort of minor issues that we've had, sort of things that we've overcome. If I have time, I'll talk about some of the cool stuff that we've done and sort of like project setup, use cases, and hopefully have some time for questions. So I'll be doing an example in Python just because that's what I'm familiar with. But, as probably know, the CDK framework based on JSII, I believe, allows these projects to be written in different languages. So I'll be using Python, but TypeScript is also supported by CDK for Terraform, and more languages are likely to come. So with that, I will talk a little bit about sort of why we're interested in CDK for Terraform. As I mentioned, we have hundreds of Terraform stacks that were built in HCL, and HCL is not exactly intuitive. I think it's gets the job done. It's a superset of JSON, and reading it, working with it, editing it is can be difficult at times. It definitely gets the job done, but it is certainly not as friendly or familiar to most people compared to your average your favorite programming language. So our experience with infrastructure as code kind of started with CloudFormation. We were building out VPCs and sort of the early days of CloudFormation, even before JSON or before YAML was supported, doing it all in JSON. We ended up doing some infrastructure as code with SaltStack, which worked okay, but is always sort of lagging behind the support because in SaltStack, you'd have to write a lot of Python code, basically, or somebody has to write a lot of Python code. You end up sort of modeling things in YAML, running it through Jinja, but it was always lagging behind features. And then we ended up switching to Terraform, I think even before the workspaces feature came out. So we ended up writing a lot of custom tooling, running HCL through Jinja, and it definitely got the job done, but again, certainly not as elegant as, say, writing Python code. So kind of where we are now is, using Terraform more as an engine and not a language with or a DSL with HCL. And Terraform's awesome, and it's really fast. There's tons and tons of community support, lots of coverage basically for various cloud providers and various sort of backends or things you want to automate. And we find ourselves sort of looking under the hood less often. We can model our infrastructure in Python and obviously reading Terraform documentation, but really dealing with the ins and outs of Terraform less and less, which is kind of nice. And I really think that Terraform's CRUD model for building out new providers is really awesome. It's something that you don't really have to deal with as an end user, but I think it shows that as AWS and other cloud providers come out with new features, Terraform's really fast to support those things. And again, from an end user perspective, this Terraform for CDK for Terraform allows us to sort of follow existing development patterns. We can write unit tests, do CI, CD, following existing patterns that we follow on other projects. So that's great. So with that, I'm gonna get started on a example. Again, this is just going to be pretty simple, just what it might look like to get started with the CDK for Terraform. So let's see, I'm going to have a couple terminals open, and the first thing I'm going to do is create a directory. Nothing goes wrong. It's always kind of nerve-wracking to do some live coding. I'm going to just search my bash history for the command, and I'll show you that this is going to create a new project. Obviously, I've already installed Terraform. I've already installed CDK, TF, CLI. I'm going to create an example project. It's going to take a few minutes. This is using a Python template and local state. If you take the local flag off, you'll be prompted for Terraform Cloud integration, which is really nice for managing state. You can also use a variety of Terraform backends. So I already have a Python virtual environment set up. And what's happening right now is CDK-TF is reaching out to the AWS Terraform provider and building it dynamically. I was just going through this example last night and realizing that we've already switched to pre-built providers, so it's really much faster. You don't have to sort of build this out dynamically. So we'll get the templates updated. But if you find a provider that is not pre-built, you can always do this this step. So while that's running, I'm going to kind of show you how I develop. If I had an IDE set up, this would be really nice, but I'm kind of old school in that I just use a Python shell, and I tend to kind of tab complete to figure out libraries and how they work. So I'm going to import this pre-built provider that I already have set up. So I've imported that provider, and I can start to see what classes are available by just tab completing. Tons and tons of AWS stuff. So for this example, I'm going to set up an S3 bucket with static website hosting. So let's get the help on S3 bucket. There we go. There's the doc strings that are sort of automatically set up. And I probably have this command that's completed in my other terminal. So you can see my project is set up. I can do ls. I've got some nice friendly help that's been printed out. And I have, an example project. Just to give you an idea of the layout, this main.py file is sort of my main stack. This cdk.out directory is going to contain the synthesized Terraform output. So the CDK-TF actually just runs Terraform under the hood. And there's some other sort of scaffolding here as well. But I'll be I'll be editing this main.py file and working on adding an S3 bucket and static hosting. So let's see. Get started on that. So like I said, I tend to kind of go back and forth between an interactive Python shell to kind of figure out how the libraries work. And you saw that I already imported this provider, the AWS provider. I'm going to just copy and paste that over here and get started. I'm importing the S3 bucket. In the other window, I checked out the doc strings. So one other thing that I know I'm going to need is to set up my sort of AWS provider, defining things like my region. You may want to define credentials. I already have that set up. So let me get the doc strings on that as well. That is, here, let's see, AWS provider. All right, so we can do some doc strings on that one as well. As you can see, there's just tons of stuff. I know that, I've done this plenty of times, so I know I need to pass in a region. I'm not doing any fancy stuff like assuming roles or anything like that. So I'll switch back to my editor and import that. And I'm going to just set it up. All right. So, yeah, I guess I can give a little bit more of an overview before I get too deep into this example. So sort of the main entry point here is sort of, the app defining a stack. My stack is a subclass of Terraform stack. And then, kind of the flow of the application is just going to kind of go sort of declarative, from here, just defining resources. Obviously, you can, you have all the strengths of Python, more inheritance, classes and functions and whatnot, but we'll keep it pretty simple for this example. So yeah, so we'll set up the AWS provider here. We're mostly just kind of defining the name. And as I mentioned, I know we'll need the region. I think I'll do US East 1. And then now we can start to define some resources, such as that S3 bucket that I mentioned. As I go, I'm just going to start synthesizing, and that means converting from Python to HCL. Let's see, what did I have? Oh, sorry, I think I have two copies of this open. Oh, that's an old one I was working on last night. Let me just get situated here. Yeah, so I'm going to start synthesizing from Python to HCL just to know that I'm not introducing, syntax errors and that sort of stuff. Oops. And this, could give me a stack trace if I had a syntax error, but luckily no problems there. So I'm going to just take a quick look at what was rendered out. And there's not much there, just kind of the AWS provider setup. So now that's working. I can start to work on my S3 bucket. And as I mentioned, we're going to kind of try to build out a static website. So let's see, we'll call this bucket. And what else do we need here? Probably the name. Oh, let's check the docs. Let's see what else we might need. I will note that I tend to go back and forth between the Terraform documentation to figure out sort of what's required. And I think that, and there's some open issue about kind of getting Sphinx documentation, so auto built. It would be awesome if some of these like required things, I'm just scrolling fast. Some of the documentation was like in the doc strings. I'm sure that will come eventually. But in any case, I tend to sort of cross-reference Terraform online docs versus Python doc strings. Okay, so in any case, we'll need an ID. We're going to want to specify a bucket name and so forth. So let me see if I can get this going. All right, so we specified an ID. we will, so I mentioned a bucket name. I think I'm going to just use that in a couple places. So I'll go ahead and keep it dry and keep this going. So, okay, test. That's not taken. Bucket equals name and region. So this is so. On. All right, region equals region. And let's see, probably missing a couple things, but I'll give it a try, see if it works. Synthesize that again, see if I have any syntax errors. All right, so I do have a syntax error, and I tend to, let's see, is there anything? I'm running the same stack through Python, and oh, I didn't specify the bucket name. It's going to give me a little bit better error. That should work now. Yes, and then synthesize would also probably work now as well. So I should be able to run CDK tf deploy and create that bucket, but I know I don't want to run out of time, so I'm going to just keep going. So I have the S3 bucket, and I mentioned I wanted to do static website hosting. So that is, if I search the docs for website, I can see that there's a couple things. Website domain, the website is passing in a reference to an S3 bucket website. So that's actually another class. And I'm going to read the docs on that. So here we have S3 bucket website. Notice that I'm not going to pass in self. I don't think I need to specify an ID, but I'm going to specify an error document and an index document. So I'll switch back to my editor, import that class, and get started defining that. So S3 bucket website, I mentioned error document. I'm going to call that error.html. We're not actually going to use that. I'm pretty sure it's a required argument though. And index, and just double check the doc. Is it index document? Yeah, index document equals index.html. And now I think this is probably going to need to go above. Yeah, this is going to need to go above, right? So here, and website. All right. Now I can pass this website configuration in to the bucket. All right, see if that synthesizes. Awesome. So that synthesizes. I feel like I'm making a lot of changes, and hopefully this is going to work. But I did want to also upload a document. So let's do that. Let's add index.html here. Say hello CDK day, and upload that. So that's going to be another import. So that's going to be S3 bucket tab complete object, right? Get the help on that one and see how that one works. So we're going to upload, specify a bucket, specify a key name, and that sort of thing. So let's get started on that. I'm going to need to import it. S3 bucket object. And so after we create the bucket and configure the website, static website hosting, we're going to upload a bucket object, basically a file, uploading a file to S3. So let's try that. So we're going to just sort of identify this as the upload. That's kind of identifies, these identifiers end up in the HCL. Could basically be anything. And we're going to say bucket equals bucket name is where it's going to get uploaded. And the region. And also we're going to need the key, file name. Let's see what else. Oh, ACL. I think we'll need an ACL public read. We need a content type, I believe, as well. Type is text HTML. And in Terraform lingo or Terraform specific, we're going to want to specify that the bucket should be created and be available before the file's uploaded. So that's depends on, and we're going to say bucket, although I don't have that as a variable, but I'm going to come back and add it. So let's try that, bucket. All right, this should work. Let's give it a try. So synthesize it. I could just straight deploy it, but we'll check. Oh, I got a syntax error somewhere. So let's see if I can hunt that down. Oh man, where is it? On line 22. 22. I don't see it. Oh, I'm not on line 22. So region. Line 22 in the net. Syntax bucket name region. I don't see it. Oh, got an unexpected argument region. Init got a region. This one? I thought oh, so bucket object. Yeah, okay. So they probably don't need that here because the bucket's being created, and then that again. Okay, cool. So that's synthesized, and let's try to deploy. So CDK tf deploy should create the bucket, configure the static website hosting, and upload the file too. So this will take a couple, minute or two. Like I mentioned, Terraform's pretty fast. You get a little example output there of what's going to happen. Yes, I want to do that, so we'll follow through. Oh, I don't think I specified the source file name. Oh, and it already exists. Wait, what? Bucket name. Let's try a different bucket name. I think I'm also remembering that I want to do, I want to read in the file. So that's going to be source. It's another argument equals ... index.html. And there's the ... because Terraform's actually running in that CDK out directory. So it's going to have to go go up a directory to find that index.html file. Let's see if this works. I'm kind of running out of time, but hopefully leave a couple minutes for questions and answers and chat a little bit more. All right, so it's going. You can see here that it's deploying the stack. Yeah, while it's kind of running, let's see. Yeah, so that created. And one other thing, so you don't really get much output of what's happening, but you can bump up the log level and rerun that. And one more thing I'm just going to do here is add a Terraform output. So that would be, Terra. And sort of just kind of printing out a lot more information here. So it's going to be self, call this the website endpoint. And this is going to be value equals bucket, website endpoint, I believe. So I'm going to really bump up the log level and we'll print out the URL. As you noticed that I ran Python earlier just to kind of get a better stack trace. You can also CD into that Terraform, so CDK out directory. You can run Terraform directly. So you can run Terraform plan, Terraform apply. You'll get more output there. Oh, did it not give me a? Not give me my output. Did I not bump up the log level? Oh, I didn't bump up the log level. So we're actually, I've been using, I'm very familiar with Terraform, so I've been still running Terraform a lot, but I do like the CDK TF CLI. Yeah, so you get nice colors, you get these sort of spinners, it's very friendly, but ultimately it's kind of, very much compatible with the AWS, or sorry, the Terraform CLI. So I have tons of output here. I should have my endpoint URL here. I'm just going to copy and paste that and show you. Hopefully the website is there. Very simple. Oh, cool. It works. So there it is. Pretty simple example of getting started with CDK for Terraform using Python. That's all I really have to show here as far as the Python examples. I will just take a couple minutes to kind of wrap up. If there's any questions, I will switch over to chat and see if I can field any questions. As I mentioned that, we're still kind of getting started, but we've done a lot with it so far. We've automated Redshift, we've CloudFront, working on RDS databases, VPC, security groups, DNS with Route 53, lots of IAM stuff. We've been working on integration tests, so running the synth, running plans, checking for drift as well. There is a lot of potential here for the project. So, I see, the possibility of sort of reusing code between CDK TF and other Python projects that we have. For instance, and we're hoping to sort of open source this WAF automation framework that we wrote. And just the other day, I was like adding a static WAF rule, and got some PR comments like, "Hey, what about these allow lists that you have over in our auto blocker project?" And well, the auto blocker is written in Python, and we can do our WAF rules in Python as well, static WAF rules in Python. All of a sudden, that compatibility layer is there for us, so it's super exciting. So kind of running out of time. I can see if there's any questions. I think it's something like CloudFormation include. Not sure about that one. Yeah, let's see. I don't think there's any other questions here. There's a note about sort of complicating things, loops and conditionals. Yeah, I mean, the example that I went through is pretty simple, but kind of some of the other cool things that we've done are kind of like setting up our Terraform state. I mentioned, you have all the benefits of Python. So if you think back to the example that I did with sort of an example stack. So one thing I have sort of, we call it a shop style stack, where we can inherit our shop style stack, set up our state. We're reading in. I did some work to have sort of like a reusable data stack where if there's a YAML file, a YAML config file in each stack, we'll read that in automatically. We have sort of like more of a global a YAML config where we can define things like Amazon account IDs, VPC IDs, some things that are sort of built out in other places, just to kind of get started with scaffolding. We also, I think it's kind of interesting to decide what are you going to do in Python versus sort of like what are you going to do in Terraform data lookups as well. We can also have all of the flexibility of Bodo, so things like, again, just reading in an Amazon account ID or other things that might be defined before you get started with this project. Super flexible there. yeah, so I'm kind of out of time. Doesn't look like I have any questions here. So if turn it back over. And thanks again to everyone for making this possible.
All right, Charles, thank you so much for that talk. One of the things that it always comes up a lot with any of these projects is where's the Python code? Where's Python? People really love Python as a language, and it's always sort of a second-class citizen in some way. So it's really awesome seeing you do that demonstration. Thank you so much for that.
Yeah, my pleasure.
Really appreciate it.